Awesome. So this combines what we were doing first with factoring. Remember the first thing we did with factoring, we looked in all the terms and saw the number that was in common, pulled it out, and looked at the variables in common and pulled them out. That was the greatest common factor factoring. And then yesterday we looked at trinomials and the opposite of foiling. Well, sometimes you have both of those things combined. There's a common factor, and then you're left with, after taking a common factor out, a trinomial that can be factored even further. So for this first example, can you see the common factor in all of them? A 3. So what we can do is we can pull that 3 out of each of those 3 terms. The first term, if we pull out a 3, we'd be left with x squared. Second one, if we pull out a 3, we'd be left with 5x. And the last one, if we pulled out a 3, we'd be left with 6. So after pulling out the 3, inside the brackets is still a trinomial. So then you'd have to ask yourself, is it possible that this was something that was foiled to begin with? Sometimes it's not possible, but as a process you'd say, okay, I still have my 3 out in front. I'll set up my brackets as if it was something that could be foiled, and based on the fact that this was our first one, this is our last one, and the outside and inside would be a 5x, is it possible? Well, the first one would have to be x and x. Now the last one's 6, and both 2 and 3 make 6, and 6 and 1 make 6. And 2 and 3 add to make 5, and 6 and 1 subtract to make 5. So which one will it be? Do you remember that we talked about that giving us a hint? Should the 2 numbers, the outside and the inside, add to make 5 or subtract to make 5 if the last one's positive? They should add to make 5. Of course, if you don't remember that as a hint, you can put 2 numbers down. Probably you would guess 2 and 3 first. Most people guess 2 and 3 before 1 and 6. So if you try 2 and 3, to get positive 6 and a positive 5, they both have to be adding. Do a quick FOIL. Does it work? Is the outside and inside 5x? Yes. So this is factored completely. We had to first take out the common factor, and then we were left with a trinomial that we could factor further. Here's another one for you to try. Okay, how did you do? Did you see that the number you could pull out of all of them was a 2, leaving you with 3x squared plus 10x minus 8? Then, if this could be factored further, here's our first, here's our last, our outside and inside combined. It would have to be 3x and x to get that first one, right? Our last one is an 8, and we need the outside and inside to combine to get 10. What number did you try first? 2 and 4? So if we put 2 here and 4 here, can you see that my outside is 12? My inside is 2. Does 12 and 2 ever make 10? Yes. If we make our 12 positive and our 2 negative, then we will get positive 10. One more. This one, the number that you can pull out, you probably saw the 5 right away. Could you see that there's also a variable in common in each of the 3? All 3 of them have a y, so you can pull out that y as well. When I pull out a 5y, for the first term, when the 5 and the y are taken out, I'm left with an x squared. For the second term, when a 5 and a y are taken out, I'm left with 7x. Finally, in the last one, I'm just left with 12. Inside the brackets is a trinomial. So then we see, could this be the reverse of FOIL? Well, if it could be, this would have to be x and x, two numbers that multiply to 12, and then the outside and the inside needs to make 7, while 4 and 3 will work. And this is factored completely. What is happening right now is we're learning an algebraic skill, okay? You're just learning the skill. You might be wondering, why would I ever want to do this? There's tons of applications that are going to come up in grade 11 and grade 12 that the skill of factoring, you need to know how to use it well. The way that it's taught in grade 10, you're just taught how to do it. And right now you might be wondering, why would I want to be doing this? But I'm going to tell you that it's a skill that's going to be used. You can, for example, this skill can be used to model, if you throw a ball up in the air, that equation that that ball makes as it flies through the air and later hits the ground. You can find out when it hits the ground by being able to factor like this. It's just one example of where this could be used. And we'll look at those things as we go along. But right now, we're just building your algebraic skills. So when you get to those questions, you're comfortable and able to solve them. Okay. Now, there are sometimes factoring questions that are so difficult that this method of reverse FOIL is difficult. Because, here I'll give you an example. Here. If we had something like 6x squared first and minus 15 at the end, it might take you a while because the first one has more than one option, right? It could be 3 and 2 or it could be 6 and 1. The last number has more than one option because it could be 15 and 1 or 3 and 5. This one probably wouldn't even take you that long if you used the reverse foiling technique that we've done. But if you chose 3 and 2 first and it happened to be 6 and 1, you'd have to go through all the possibilities with 3 and 2 and find out none of them work. And then you'd have to switch over to 6 and 1 and go through all the possibilities of 6 and 1 and find out maybe there's the one that works. So it could take a long time if you guess wrong to begin with which one you're going to try. So we have a technique for ones like this that's a little bit longer technique, but on these questions that guessing which ones would work first might take a long time anyways, it's a nice technique to solve the whole thing. Here are the instructions, and I'll give you some time to write them all down. I'll make it a little smaller here so you can see it all at once. If I make it that big, can you still read it at the back? Or is it a little bit small? Xander, you're able to read it? Patsy Ann? It's good? Okay. And then I'll move it down in a bit. So here is the first question. So the first thing it says is to look at the first and the last term. Go slide this up. The first thing is write down the product of the first and the last term and then write down the middle term as a sum. So what we're going to do here is we're going to put P for product, and the product is equal to 6 times negative 15. 6 times negative 15 is negative 90. And the sum is our middle term, which is equal to 1. Once we find our product of negative 90, and we know that the sum is supposed to be 1, what we're going to do is we're going to look at different numbers whose product could be negative 90. Some people insist that you write down all possibilities. Now, that's very time consuming because one of the possibilities to multiply two numbers to get 90, negative 90, would be 1 and negative 90, right? Would you agree that 1 times negative 90 is negative 90? But if I add those together, and that's what we'll put under our sum column, we'll get negative 89. Does that equal to 1? No. Two other numbers, well, you could have also had negative 1 and 90. I hope after adding the first two to get negative 89 that you wouldn't decide as your next one to try just switching the negative. Okay, now that one adds to 89. Does that equal 1? No. We're sort of doing the same process that we did before, right, with the outside and inside, trying to make the number work. Can you see two numbers that make 90 that add to 1? Two numbers that multiply to 90. That when you add them together, no, sorry, multiply to negative 90. That when you add them, you'll get positive 1. 10 and negative 9. 10 times negative 9 is negative 90, right? And when I add those together, I get 1. So this is the first step. It's actually the first and second step. If we go back to our list of steps, we first wrote down the product of the first and last term. That was our P. And we wrote down the middle term. That was our sum. We just did the second step. We looked for two numbers whose product was the one number, that negative 90, and the sum of those two numbers was the other number, the 1. So we did step 1 and step 2. Now what we do is we go and we rewrite the middle term, which is the x, as, so I still have 6x squared. I'm still going to have minus 15. That's my first and my last terms. But now my middle term, I'm going to write out as these two numbers, plus 10x minus 9x. Can you see that my next line is equal to the line before? But I've undone something, right? Because when you FOIL, the outside and the inside get combined. What this process does is it tells you what the outside and inside were before they were combined. So we know that our outside was 10x and our inside was minus 9x. Once you have these four terms, be careful because you're so used to combining like terms that your next step you might combine your like terms and get back to where you started from. That's not the process we want to do here. What we want to do now in step 4 in our notes was looking at the four terms, see if there's a common factor in the first two. So if I look at the first two, 6x squared and 10x, is there a number in common that would divide both of them? 2. Is there a variable in common in the first two? X. What would I be left with after I take out the 2 and the x? I'd be left with 3x plus 5. That's what happens when I looked at the first two. Now when you look at the second two, what you want to have happen is you want to have this 3x plus 5 come out again. So again, look for a common factor between the numbers. It's going to be a 3, but in order to get a positive 3x out of a negative 9x, I'd have to pull out a negative 3. Can you see that? And that was an example we did before. I said sometimes you want to pull out the negative and sometimes you would want to leave the negative inside. In this case, with the negative 9 and the negative 15, I'm going to want to pull out a negative 3. And when I pull out a negative 3 out of those two, I'm going to be left with positive 3x plus 5. The key is that those two binomials have to be the same. Because technically, what we have now is one big term here, subtract another big term there. And we can use common factor factoring one more time. Okay, this is sometimes harder to see. I'm going to highlight some things here. This is one big term in yellow. This is another big term in green. We've got the yellow term, subtract the green term. Can you see that there's something common in the yellow and the green? The 3x plus 5 is in common in both the yellow and the green. So as far as factoring goes, I can take that out. 3x plus 5 can be taken out of the yellow. Put brackets here because that's how we factor. If I take the 3x plus 5 out of the yellow, what would be left? 2x. If I take the 3x plus 5 out of the green, what would be left? Negative 3. Let's do a quick check. Do my first ones multiply to give me 6x squared? Yes. Do my last ones give me negative 15? Yes. Do my outside and inside make 1? My outside makes the negative 9, just like we saw here. My inside makes 10. And it works out. In fact, if we go back to this step, if we would multiply this out, if we'd multiply, this would be our first ones. If we'd multiply this, this is our outside ones. 5 times 2, this is our inside one, and this is our last one. So it's fuel, which doesn't quite have quite the same ring as foil. But this is the process that comes out, and this is a technique that really works backwards to get there because it breaks up what the outside and inside would have multiplied to be. And there will always be, when you have something like this with no common factor to take out, there will always be only two numbers that will work out to the product and work out to the sum, if it's possible to factor. How many people still think for this one that they could have just gone to here right away and guessed and checked faster than this technique still? Maybe. Maybe you could have just said 3x and 2x and then tried different things until you got the 3 and 5 work. I bet you a number of you could still do the other technique faster than this for this example. But I want you to try this technique for this one. So let's see how you did, see how many steps you were able to get. 4 times 9, that'll make our product equal to positive 36. Our sum is the middle number, negative 15. Trying different numbers. Now, if you can't see it right away, just put two numbers down that you do see that multiply to 36. Maybe you see 6 and 6 is the first one you see for 36. That adds to 12, which is not negative 15. But by doing that, you might say to yourself, okay, all my positive numbers that work will give me positive numbers when I add. The other way that I could get 36 is using negative numbers. That still doesn't work, but at least doing that first example told you some information. I shouldn't think of just positive numbers. I have to think, how would I get a negative number? And so both of my numbers are probably going to have to be negative. Now, what else multiplies to 36? Maybe you think 4 and 9 in your head, but you add that together and gets 13. 12 and 3. Negative 12 and negative 3 would give us positive 36, and that works out to negative 15, so we know that those will be the numbers. So we can go to our equation again and write 4x squared, and this middle number now we can write as minus 12x minus 3x plus 9. Now, did anyone write 3 and 12 instead of 12 and 3? And it won't make a difference. It won't make a difference if you wrote the 3 first or the 12 first. Your factoring will look a little bit different in the next step, just because the common factor you pull out will be different, but it will work out to be exactly the same. I'll do it over here just so you can see how it's exactly the same. Okay? So if you had the 12 first and the 3 first, when I look at my first two terms and I say what's in common, there's a 4 and an x. And what would come out then would be an x and left with a minus 3. I want to get another x minus 3. So in my last terms, I'm going to have to pull out the negative 3 instead of the positive 3. Pull out a negative 3 out of the second two terms. That'll give me the positive x that I want. And negative 3 times a negative 3 gives me positive 9. So if you chose the 12 and the 3, that's what it will look like in the next step. If you'd chosen the 3 and the 12, in the first two, the only thing that would be in common is an x, leaving me with 4x minus 3. And in the second one, there's a 3 in common, but I want to get a positive 4x, so I'm going to have to take out a negative 3 to get that positive 4x. And negative 3 out of 9 will give me minus 3 as well. In both examples, we now have, just like we highlighted before, we have a green term here, green term here. We have our yellow term connected here, because terms are connected by multiplication. And in both the yellow and green, there's something in common. In the one on the left, what's in common is an x minus 3. And when I pull an x minus 3 out of the yellow, I'm left with 4x. When I pull an x minus 3 out of the green, I'm left with minus 3. If you had done here on the bottom right, now there's a 4x minus 3 in common. And if I pull out a 4x minus 3 out of the yellow, I'd be left with an x. And if I pull a 4x minus 3 out of the green, I'd be left with a minus 3. And the answers are identical, just the order is different. But 5 times 3 is the same as 3 times 5, so that doesn't matter. Now we're going to do some more with ones we're going to use. I hope you can see opposite of foiling. You could factor this one super fast the other way. But I want to show you that the grouping technique works even with the easiest ones. How many people are able to factor this as x minus 9, x minus 4? The star means I put it there to say the easier technique is this one. This is the easier technique. And I would hope that you always do the easier technique first. Because I said 98% of the time you can just do the opposite of foiling. The first ones have to make an x squared. Well, that's easy. That's x and x. The last ones have to make 36. Outside and inside need to make negative 13. So that's the way I would want you to factor this. But I put a star there because I want you to try the grouping technique anyways. Not sure how long it took you to figure out negative 9 and negative 4 make negative 13. Maybe you're able to get it on your first try. And then we would write x squared minus 9x minus 4x plus 36. What's in common in the first two is an x, leaving you with x minus 9. In order to get a positive x inside, I would need to factor out a negative 4, leaving me with x minus 9. What's in common in both those? An x minus 9, leaving me with x minus 4. Would you agree that the original technique is faster and takes up a lot less room? And what's going to happen for this tool is later on, you're going to be doing some math that takes like 3/4 of your page, right? And this would be one step in that 3/4 of page. So doing a big technique like this isn't very useful, whereas if you could just go to a single line, it'll be more useful for it. So that's why we always try to use the reverse FOIL technique first, because it takes up less room and it is faster. So for this next one, I want you to use the reverse FOIL technique first. And then we're going to use the grouping technique. But it's nice to have two techniques, because sometimes if you're using one and it's just not working, then it's nice to have the other one to check. And remember the example yesterday that we had that didn't work? So the way that that would show up with the grouping technique is when you'd list every single possibility that could be a product and none of the sums match up, then you know it's not factorable. Okay, first off, were you able to see that it have to be 2x and x? To get 5, it has to be 5 and 1 or 1 and 5. But in order to get the 11, we need the 5 over here. So our outside is 10, our inside is 1, and that makes 11. They both have to be positive to get the positive 5 and the positive 11. As far as our grouping one goes, product would have to be 2 times 5 is 10. Sum would have to be 11. And the only way to get that is 1 times 10 is 10, and 1 plus 10 is 11. So we're left with 2x squared plus x plus 10x plus 5. Only thing common in the first ones is an x, leaving us with 2x plus 1. The only thing common in the next ones is 5. Need 2x plus 1. Ooh, I'm gonna do this one also in another way, because I want to show you something in this one that sometimes comes up. So I'm going to write it as 2x squared. Did anybody write the 10x first and then the x next? Did anybody do it that way? Okay. There's something neat that comes up when you do it that way. I'm going to show you that in a second. But let's finish the one on the left first. There's a 2x plus 1 in common. And out of the first one, all that would be left is x. Out of the second one, what would be left is 5. If you had done it the second way here on the bottom right, in the first two terms, you could pull out a 2 and an x, leaving you with x plus 5. But in the second two things, there is nothing in common. So what you can pull out, if there's nothing in common, is a 1. And when that comes up, we'd still be left with x plus 5. And I put this example in your notes for that reason, because sometimes you're like, there's nothing I can pull out. Is it wrong? But you can always pull out a 1. Then we'd be left with, the common thing would be x plus 5. Out of the first one, you're left with 2x. Out of the second one, you're left with 1. So it's good to see that as well. Now, I did make all of the examples that we've had here for grouping. There could be an argument that each of them would be faster using our old technique of reverse FOIL. So I tried to think of one that would not be fast whatsoever with our old technique. That doesn't mean it's going to be fast with grouping, with this technique, which is called grouping or decomposition. However, I think that grouping or decomposition technique will be faster with this one. Are you ready? It's a little nasty. Are you able to handle that this morning? A factoring one that's a little nasty? Michaela says no. She's done. Anybody ready for a challenge? Anybody want to take the challenge? A lot of people say no. If you're not ready for the challenge, here's your homework. If you are ready for the challenge, here's the question. Anybody see the news article that said Manitoba students are the lowest in reading, lowest in science, and lowest in math in all the country? Did you see that news article? And I ask if you want to do a challenge question, and everybody says no. Do teachers give in then? Is that the problem? Students say we don't want to work hard, and teachers say, okay, that's all right. I'll put the answer up for this one in a second. You can go to your prime factorization. Do you see that 480 is 48 times 10? And 48 happens to be 6 times 8. And 10 is 5 times 2, right? And maybe you can see from here that this is 2 times 3. 8 is 2 times 2 times 2. And now I've got my prime factorization. So if I want to see two numbers that multiply to give me 480, I can just pick groups of these. What number do I get if I pick those ones? 2 times 3 times 2. 12. And what am I left with when I have 2 times 2 times 5 times 2? That'll be 20 times 2, 40. Does that make a difference of 17? No. But now I can choose different groupings of 3. Maybe I choose 2 times 2 times 5. That makes 20. I've done that one. What about 2 times 2 times 3, which makes 12 times 5? That makes 60. That would leave me with 60 and 8. That doesn't work. So we have to keep working at breaking this up. What if I put the 3 and the 5 together? That makes 15. And I'd be left with 2 times 2 times 2 times 2 times 2, which is 32. Oh my goodness. Check this out. If we make the 15 negative and 32 positive, we get 17. And I'm saying this is the faster technique rather than reverse FOIL. It's still pretty long. And so now I can write 16x squared minus, do it in green, minus 15x plus 32x minus 30. And I can factor out an x out of the first two, 2 out of the next two. Look at that. So this one factored completely is 16x minus 15 times x plus 2. On a scale from 1 to nasty, where would you put this question? Really nasty, okay.